Let's solve more questions on factor theorem. And these questions are a little bit different from the ones we have already solved and maybe a bit more difficult as well. Now we have seen what factor theorem is. We have been solving questions on factor theorem for a little while. Now let's try and factorize this particular polynomial using factor theorem. Now one thing you will notice, the difference between this polynomial and some of the polynomials we did solve earlier is that the coefficient of the x squared term is not 1, right? So whenever we have something like this, the way we are going to write our polynomial is we are going to make the coefficient 1. In other words, we will take 2 common out for the entire polynomial. So we are going to rewrite the polynomial as, we will take 2 common out, and that means we have to divide each of the term by 2. So we will get now x squared, we will get minus 5x by 2, and we will get minus 3 by 2. So this is what we have. Now let's try to find out the factor of this polynomial, right? So let's assume that this polynomial, so now we have this 2 over here, 2 times this, right? So our factors are 2 times x minus a times x minus b. So if this is how we are going to have our polynomial written, then the AB term, which is a times b, that term, the AB term or a times b, will be equal to minus 3 by 2. So it will be minus 3 by 2. So what are the different factors of minus 3 by 2? Well, we can write the different factors of minus 3 by 2 as, we can have the number 1, we can have the number 1 by 2, we can have the number 3, and then we can have, let's see, did we miss anything here? I think these are the various combinations, right? So obviously we have to factor in the sign. So this will be plus minus 1, this will be plus minus 1 by 2, and this will be plus minus 3. In other words, we can have a situation where, oh yes, we did miss out plus minus 3 by 2. So these are the 4 factors, right? So now here we are going to use the factor theorem and find out the value of this polynomial, the one we have inside, because x minus a times x minus b, these are factors of this polynomial inside, right? So now we are going to find out polynomial, so each one of them, right? So we are going to find out the value of this inside polynomial at 1, and then similarly at minus 1, at plus 1 by 2, then minus 1 by 2, so on and so forth, and find out which of them gives us 0. Then we know that that will be the remainder, and from there we can find out the factor. So let's do P1. So if we have P1, so we will put the values here. So we will have x squared, so we'll have 1 squared minus 5 by 2 times 1 over here minus 3 by 2. So if we solve it, we will have 1 minus 3 by 2 minus 5 by 2 minus 3 by 2. So if we solve this, we will have 2 in the denominator, get 2 minus 5 minus 3. So if we do this, we are going to not get 0. This is not 0, right? Let's try the value of polynomial at minus 1. So again, this is a polynomial, right? So at minus 1, we will have minus 1 squared minus 5 by 2 times minus 1 minus 3 by 2. Or we will have 1 plus 5 by 2 minus 3 by 2. So this will be, we will have 2 as our LCM. So we will have 2 plus 5 minus 3. So this will again not be equal to 0. Let's try plus 1 by 2. So let's see if we have enough space here. So plus 1 by 2. So P of plus 1 by 2. So it will be 1 by 2 whole square, which is x squared, minus 5 by 2 times 1 by 2 minus 3 by 2. So 1 by 2 times 1 by 2 is 1 by 4. Minus, this will be 5 by 4 minus 3 by 2. Now here 4 will be the LCM. So we will have 1 minus 5 minus 6. So this will be, again, this is not equal to 0, right? This is not equal to 0. All right, let's keep going. Now let's find out. So let's give ourselves a little bit more space. Now we want to do polynomial of minus 1 by 2. So let's write our polynomial over here. So we want to write our polynomial, this polynomial, right? So 2 times x squared minus 5x by 2 minus 3 by 2. So let's write it over here. So this polynomial is now 2 times, we should write here, x squared minus 5x by 2 minus 3 by 2, right? And we are trying to break this into 2 factors. And our factors that we are exploring right now, they are, we tried plus minus 1, that did not work. Now we are checking plus minus 1 by 2. So we checked the plus 1 by 2, that did not work. Then we will check plus minus 3, and then we will have plus minus 3 by 2. So for minus polynomial at minus 1 by 2, if you put the values over here, let's see what we get. So minus 1 by 2 squared minus 5 by 2 times minus 1 by 2, and then we have minus 3 by 2. So this will be 1 over 4. This will be plus 5 by 4 plus 5 by 4. This will be minus 3 by 2. So now here our denominator will be 4, and then we will have 1 plus 5 minus 6. Now here 1 plus 5 is 6 minus 6 is 0. So this is indeed 0. So we know this is one of the factors. So remember, we actually have a times b. We are trying to find out a times b is minus 3 by 2. And now we have figured out this minus 1 by 2 is a factor. That means minus 1 by 2 is a factor. So can you guess the other factor? Of course, the other factor is 3. So we don't have to check minus 3 or this entire term. So if we just check for 3, we should get that as 0. In other words, let's go back here. Let's just find p of 3. So it'll be 3 squared, right? It'll be x squared. So 3 squared minus 5 by 2 times 3 minus 3 by 2. Or 3 squared will be 9 minus 15 over 2 minus 3 over 2. So here we will take 2 as LCM. This will be 18 minus 15 minus 3. Minus 15 minus 3 is minus 18. 18 minus 18 is 0. And yes, indeed, this is 0. So now, so the factors of this are these two. In other words, our original polynomial, this polynomial, we can write our original polynomial as now 2 times x minus 1 by 2, right? Because this is a factor, and then times x minus 3. So these are 2 factors. Now we can actually we can clean this up. We can rewrite this in the form of, let's do it over here. So we have 2 times, this will be simply x plus 1 by 2 times 3x minus 3. Or we can write this as, we can actually simplify this. So we will have this 2 which is outside, and then this will be 2x plus 1 divided by this 2 times x minus 3, or simply these 2 will cancel out. So our 2 factors are 2x plus 1 times x minus 3. Now this may seem like a whole lot of work, but this is how we can actually solve questions, and we can try to factor polynomials using factor theorem. In this particular case, it might have been much easier if we may have tried to do maybe middle term factorization. So, but I just wanted to give you an example of a relatively difficult question when it comes to using factor theorem to factorize polynomials. Now let's take a look at one other type of question that we have not seen so far. Now find the value of k, where k is any number, if x minus 1 is a factor of this polynomial. So we have been given a polynomial, and so let's write our polynomial. So we have been given a polynomial px, which is this, and it is written in terms of k, right, where k is any real number. So our polynomial is x cubed plus 2x squared plus x plus k. And what is given is the fact that x minus 1 is a factor of a polynomial. That means if we divide this by x minus 1, remainder is 0. So then we know that from factor theorem, if this is a factor, then the remainder, which can be found by value of polynomial at x equals 1, must be 0, right? It follows from the factor theorem. So if we simply find p of 1 and we equate to 0, then we can use that equation to find k. So let's find out the value of polynomial at x equals 1. So this is a polynomial. So we can write this as, so p of 1 will be, wherever we have x, we'll replace it with 1. So 1 cubed plus 2 times 1 squared plus 1 plus k. Or what we have here is 1 cube is 1, plus this will be 2 plus 1 plus k. Or simply we have, this will be 4 plus k. Now this must be equal to 0, right? So from here we can say that k will be, we take the 4 on the other side, and we will get k equals minus 4. So this is one other type of question that you may get, where you may have to use the factor theorem to solve these questions. And if you are really curious, you can put k in here. That means, and then actually do the division and check out whether the new polynomial can be divided by x minus 1. In other words, we can rewrite the polynomial as x cubed plus 2x squared plus x minus, k is minus 4. So we can write minus 4. And you can actually do the long division here. And we are dividing this by x minus 1. And if you do the long division, you will indeed see that the remainder is 0. So let's try and do really fast over here. So we'll get x squared. This will give us x cubed minus x squared. Then this will cancel out. So this will be 3x squared. 3x squared plus x minus 4. The next term will be plus 3x, yes, plus 3x. So that will give us 3x squared minus 3x. And now when we subtract this, cancel out. So this changes. We get 4x minus 4. We divide 4x by x, we get plus 4. When we get plus 4, we get 4x, and this will be minus 4. And indeed, when you subtract, both the terms cancel out and the remainder is 0. So indeed, when we have k as minus 4 and we divide by x minus 1, we see that our remainder is 0.